Hey everybody, today I want to teach you guys about combinations and permutations, which are some of the basic ideas that are necessary in counting theory and some probability theory. Before we get too deep into things, I want to make sure you're aware of a special sequence called a factorial. Factorial is a symbol with, or a number with an exclamation point behind it. And a couple examples of that. Just the simplest thing, 1 factorial is simply 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. And so 4 factorial, as you guessed it, 4 times 3 times 2 times 1, or 24. And in general, something factorial is simply that number and all the products multiplied all the way down until you get to 1. There's one special case, and that is a 0 factorial, for reasons that aren't necessarily obvious, is also defined as 1. Now, let's see how that plays into some specific examples. So, one of the first important ideas in counting theory is the concept of a permutation. So, a permutation is when you take a set of objects and you put it in some sort of an order or arrangement. So a permutation is an arrangement of different things. For instance, I might want to take just the 5 letters in my name and see how many different orderings I have for those. So I've got R-O-C-K-Y, I've got R-O-K-C-Y, and R-O-Y-C-K. There's 3. I could put the R in the middle and the O at the end, or the C. There's one, Corky. Anyway, there's at least 7 or 8 different arrangements I have right there. How many are there total? One tool that you can use to answer that sort of question is to write a series of blanks. I've got 5 blanks because there are 5 spots where I could put letters. And just think about how many letters could I put in this first blank. I could put any of the first 5, right? But after that, after I've chosen 1 letter to go in that first blank, there's only 4 that can go in the next blank. And so of all the 5 that I had chose, now there are 4 more for each of those. So that's times 4. And in the third blank, there's only 3 letters left. And so for any of those 21st orderings that I could have 3 branches off of that, if you will, and so on, and 2 here. And once I've chosen the first 4, there's really only 1 letter left to go in the last spot. And if you were to multiply 5 times 4 times 3 times 2 times 1, that's how many different ways there are to arrange the letters in a 5-letter word. In general, there are n factorial ways to order n items. And so that's one of the reasons the factorial is such a popular sequence. Here's a similar type of question, only this time it says how many different ways are there to arrange all the letters in the word Mississippi. So got lots of different things here. I could move the I over here, or the S here, or I could move the S here, or I could move the I here. Oops, I could move this I here, or I could move this I here. In general, a question like this, you can answer by saying how many total letters there are, that's n factorial, and then dividing by, for every letter that repeats, how many times that repeats, factorial. I'm sure that's clear as mud, right? So in the word Mississippi, there are 11 letters, and so if we wanted to find that, what we need to do is take 11 factorial on top. And then for each of the letters that repeats, M repeats, well, it doesn't repeat, it occurs once. And the I's, there are 4 I's, so that's why I'm going to divide by 4 factorial. There are 4 S's, and there are 2 P's. And so if you were to take 11 factorial and divide it by 1 factorial, and 4 factorial, and 4 factorial, and 2 factorial, you'd have your answer. So I'm going to type this in my calculator here. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then I'm going to divide by, in parentheses, 4 times 3 times 2 times 1. And divide again, in parentheses, by 4 times 3 times 2 times 1. And one more of them. wait, there's only 2 p's at the end, right? So not 4 times 3 times 2 times 1, just 2 times 1. And whew, that's a big number, 34,650. A lot of times, instead of taking all the items in a list and putting them in order, we want to just choose a few of them. For instance, suppose we have the race, the Kentucky Derby. It's 15 horses running in this particular race, and want to know how many different ways are there of picking the first place runner, the second place, and the third place. So to answer that question, I think that tool that we saw earlier might work. In this case, instead of having 15 blanks, I only care about the first 3 places. And in this first blank, there would be 15 possible horses that could place first. And in the second blank, there might be 14 horses. And in the third blank, there'd be 13. And if you multiply 15 times 14 times 13, that would be the answer to this. Calculator tells me that that is 2,730. Now, this question is so popular that it has its own notation. We say when we have 15 items and we want to pick and put in order just 3 of them, that's an abbreviated NPR, standing for a permutation. And a formula for that exists. On top, we put n factorial, and on the bottom, we put n minus r factorial. Specifically for that last problem, what we just found was 15p3. And that means on top, we've got 15 factorial, and on the bottom, we've got 15 minus 3 factorial. That's very different than what I typed into my calculator. I typed 15 times 14 times 13. I didn't type this fraction in here. Let's see what this looks like if we write it out. 15 factorial would be 15 times 14 times 13 times 12 times 11 and 10 and so on. I'm going to purposefully not write 12 factorial because 15 minus 3 on the bottom is 12 factorial. And cool thing about this formula is the 12 factorials end up canceling out. We end up with exactly what I typed in, 15 times 14 times 13. So that's the permutation formula. Here's a question that combines those two ideas. How many different ways are there of arranging just 5 of the letters in the word Mississippi? It's a challenging question, and in short, I'm not going to answer it today. It's not as simple as simply making a couple blanks and putting in some numbers and multiplying things. It does have a really cool application of polynomials that I'd like to make a video of and show, so I hope that you guys will check back up here sometime for the link and watch that video, but right now it doesn't exist. So another important idea in counting theory is a combination. A combination is a set of objects that you choose out of a different larger set of objects. And an important concept is that 2 combinations of the same objects in different orders is only counted once. And so a lot of times people say the order doesn't matter in combinations, whereas permutations, it certainly does. Little example of that. How many different combinations of 3 shapes could I choose out of the 7 that are here? So I could choose heart, circle, and rectangle. I could choose flag, arrow, and cloud. I could choose cloud, arrow, and no, that would be the same. Cloud, arrow, and flag would be the same as, so I wouldn't count that as the second one. See what I mean by the order doesn't matter? So anyhow, how am I going to possibly count all those? Well, you could try just 1, 2, and 3, or maybe 1, 2, and 4, or 1, 2, and 5, 1, 2, and 6, 1, 2, and 7, and it is possible to list them in a decent order that makes sense so that you list them all and count them and don't count any of them twice. Here are them, and I just noticed that this, I've got a little triangle here, and I've got the bowling triangle number here, and then here's another triangle, and so forth. But anyway, you could list them and count them. This isn't that big of a problem. But if I had, say, 40 items and I wanted to choose 7 of them, or 52 items and I wanted to choose a hand of 5 of them, like in cards, you wouldn't want to list them all like this. In general, the number of ways that you can choose R items out of a larger group of N items is a popular enough type of question that it has its own notation. That would be abbreviated NCR. And it's similar to NPR, right? Only for combinations instead of permutations. The example we were just looking at, we have 7 shapes and we're trying to choose a group of 3 of them, would be 7C3. And the formula is 7 factorial and 7 minus 3 factorial on the bottom times 3 factorial. So kind of a complicated looking little thing, but on top that's just 7 times 6 times 5 times 4 times 3. 7 minus 3 is 4 factorial, and this is 3 factorial. And so you could totally list that off. 7 times 6 times 5 times 4 times 3 and so forth. It looks overwhelming, but because there's so much that's the same on top and bottom, like you could cancel out all these 4, 3, 2, 1s on top and bottom, you end up with a 7 and a 6 and a 5 on top, and the 3 and the 2 and the 1 on the bottom here. And 3 times 2 is just 6, and so those reduce away, and so I really could find this in my head. It's 35, 7 times 5. So that's the combinations formula. Blaise Pascal made a famous triangle that calculated these combinations. This is called Pascal's triangle. You've probably seen it before, but it's just a bunch of 1s on the outside and one very simple rule, and that is that inside is always the sum of the 2 squares or triangles right above it. And so note this 3 is 1 plus 2, as 15 is 5 plus 10. And this number right here would have to be 7 plus 21, which is 28. What's shocking, really, about this triangle is that it's not just a bunch of random numbers, but each one of these numbers is one of those combination questions. And so if you wanted to look up specifically the question we found, 7 NCR3, you go down to the row with the 7 in it. And this is 7 NCR 0, or effectively, how many ways are there of choosing no items, no shapes out of 7? There's one way to do that, right? There's 7 ways you can choose 1 shape out of 7. There's 21 ways you can choose 2 shapes out of 7. And this was the question that we were looking at, right? There are 35 ways that you can choose 3 shapes out of 7. Before I go, I wanted to show you just a couple of tricks that you can use on your calculator to find these. While you can type them in by hand and write them out by hand, it's definitely faster at times to do this on the calculator. All of these tools, NPR and NCR and the factorial symbol, they can all be found in the Math menu. If you press the Math button, and then you go over to the probability submenu, you'll see these. I think NPR is the 2nd item in that list, NCR is the 3rd item in the list, and factorial is the 4th item in that list. So anyhow, it's pretty easy to make those calculations that way. I want to leave with one last question, and that is simply, what is the first 5 terms in the 52nd row of Pascal's triangle? So the naive way to ask this question or answer this question would be to simply build a triangle. You know, start with the 1s and then 1 1 and then 1 2 1 and 1 3 3 1 and 1 4 6 4 1 and just keep adding until you get all the way down to the 52nd row. But that would take a really long time. And so how can we answer that question more quickly? Well, each of those are a combination. And so if you wanted to, you could calculate it by doing 52 and then going into the Math menu and choosing NCR and then 0. That would be the first number. That should be a 1 because there's one way to choose no cards out of 52. You could then do 52 NCR 1 and 52 NCR 2 and so forth if you wanted to do each of them separately. Another trick that you could do is you can use a list. Since I want to create a list, I could say 52, and I want to choose 0 or 1 or 2 or 3 or 4. This would be the first 5 items in that list. If you want, most card games have 5 cards in your hand, and so it might be nice to go one more since this definitely has an application with cards. So you could type that in. Those braces are second parentheses. We'll make that happen. And if you wanted to produce the entire row, for that, rather than typing out a giant list and going all the way to 52, I might suggest you use the sequence command. And so I'm going to type that out here. Sequence, remember that requires 4 arguments. It requires a formula, and then a variable, and then a start and a stop. And so the formula is 52 NCR something. And I'm going to let that variable x go from 0 all the way to 52. That would produce the entire row. And if you just wanted the first 5 numbers in that list, then you could type this in. So a handful of different ways you could answer it. I would encourage you to try. Let me know if you have any questions, and I'll be glad to help. See you later.